Keep your device on. Okay.
Am I audible now? Audible. Hmm? थोड़ी आएगी। Okay. Good afternoon again. I'm Dr. Ravi. I'm the coordinator of this program. And as per the schedule, we were supposed to have Mr. Manoj Kumar K, who is a scientist at InflibNet. Unfortunately, he'll not be able to join us today. He'll most likely be joining us in sometime later on. So today I'll be discussing about what LaTeX is and how we can use it for our document preparations. I believe most of you already know about what document preparation or document processor is. A basic document processor is, of course, Microsoft Word. You all must be familiar about Microsoft Word. So presently, of course, you have the option to go with Microsoft Word and use it for free on the web. But using it on your own computer needs purchase access. And there are some challenges with Microsoft Word. And I believe Microsoft is trying to address those issues. So similar to Microsoft Word, there are many other tools. One of the simplest tools is, of course, Google Docs. If you have a Google login, then you can use Google Docs, which is very much similar to Microsoft Word, and you just need to sign in and start using it. And of course, this is also only an online tool. You will not be able to use it on your system. So if you want to use it, then you'll probably have to download format and then use that. So similar to that, there's also OpenOffice Writer. So this is an open source tool. This is similar again to Google Docs or Microsoft Word. And this is again free to use on your system. You can download and install it on your system and then use it. And there are no licensing issues with this. But all of these tools are simple to use. But when it comes to technical documentation, when you want to document complex figures or equations, then it becomes a bit tricky. And moreover, when you're trying to go through large documents, compiling those is a problem. It takes time. The system hangs. So these are some of the common issues that come up with these simple word or document processors. So most of the technical documentation that publishers use, of course, many publishers these days are also coming up with Word or Microsoft Word templates. But previously, most of the top publishers used to uh, have only the LaTeX template for publishing. So the advantages that LaTeX offers are several. First thing is the quality that you get with LaTeX, that is unmatched. It's unparalleled. You will not be able to get the same type of quality of graphics or equations using a simple word processor. Of course, word processors by themselves do not have any in-depth capabilities of putting equations or figures. But what you can do is you generate some figures or equations using some tool and then paste it into your document. But the moment you try to upload your document somewhere, then you need to publish it most likely as a PDF or a portable document format. So that is a common format that is asked by almost all publishers. They either want the LaTeX file or they want the PDF file, or in some cases, they even accept the Word files. So when you want to, because the PDF is the general format which is asked by everyone, because that is the format which does not corrupt the presentation of the document. Because if you compile or if you compile a document using a word processor and you send it to anyone, the moment that same document is opened by some other word processor or a different version, then the syntax and the format of the document changes. And there are many issues that come up. So in order to avoid these formatting changes, PDF formats are commonly preferred because PDF formats do not change when you change your system or the accessing tool. So LaTeX has this capability of generating PDF documents and very good quality PDF documents. So the web page that I am showing you here is actually Overleaf. I hope you're all able to see my screen. So I think what I was planning to demonstrate right now is this text that can be used to generate very good figures. So if you are on a laptop, then I would suggest you can all log into Overleaf and you can have a hands-on session on how text can be used to generate figures. So Overleaf is an online LaTeX editing tool. With Overleaf, you just need to create an account. There is an option of a free plan. And if you want some additional features, then you can always go for an upgrade. So what I am using is the basic free plan. I'm able to create documents and I'm even able to share my documents with my students or my colleagues. But of course, there is a limitation. With this free plan, I can share my document, any one document with one person only. So if I upgrade, then I would be able to share a single document with more than one person. Apart from that, I'm not sure of what other options would be there in the upgraded plan, but I'm presently on the free plan. And there are many different types of documents which can be prepared using LaTeX. So, and there are several templates which are already available. So if you look at this, there are journal articles, books, formal letters, assignments, posters, presentations, reports, CVs, and resumes, thesis, and many more. So you can also make certificates. You can also make question papers using LaTeX. Means whatever document that you want can be prepared using LaTeX. There's no limitation to that. But yes, of course, it is. If it is just a single page, then using LaTeX to generate a single page document becomes a bit more time consuming. But if you are going to use that same document over and over again with just some minor modifications, in that case, using LaTeX has its advantages. So if you want to look at templates, then you can just click on view all, and there are many different types of templates which you'll be able to look at. So there are several templates, and depending on what you want, you could probably even search for what you want to create. Maybe a question paper. Yeah. So there is a template of a question paper. This was posted by someone, Engineer Mudassar Latif Memon. So even you can create your own template and you can upload it to Overleaf. Even that is a possible way of using these templates. So among all these documents, what I wanted to show is about graphics. Graphics can be made by several tools. This need not be done in only LaTeX. When you're working on graphics, usually, I'm not sure if everyone is aware of the LaTeX structure. So I'll just briefly explain about what these different lines are. So once everyone has a working LaTeX login or a login in Overleaf, you can just go to your Overleaf front Overleaf dashboard, and there this would be blank. So you can just go for a new project, and you can go for a blank project, or you can just go for these templates, uh, and you can pick any. So, and then you can try to edit those so that you can have whatever is the changes that I am discussing about. So if you're going for a journal article, you can just go for any of the journal articles. So I am just clicking the first one, and then I just need to say open as a template. So for this particular journal, if you look at the code, there's a lot of commented text. This explains about how this file is to be used and what all journals accept this particular template. So these are the journals which use this template for submission of the research articles. So here you can see these three letters. So this is what is the option depending on which journal you would be submitting your paper to. So this is the Glasgow Mathematical Journal. So this particular, on the right, what you can see is a preview of how the PDF would look like. So the first line for any LaTeX document is document class, and the document class is followed in the curly braces by this particular it's actually a type of structure. So if you remember what I had in the previous text demo file, that was a simple article. So this CUP-JNL-DTM is an advanced version of that article class. So this is actually a class file. This is defined by this command. So this class file is called by this command document class. So the document class is going to search for this particular class file. So this class file should be here. Yeah, you can see this CUP-JNL-DTM.CLS. So this is not a common class file that is used by LaTeX generally. So if you want to use LaTeX on your system, then you would need to put this CLS file separately in your folder. Otherwise, if you want to use the normal article, then you can just go for a simple there are many different templates, and it's actually difficult to okay let me yeah. So let me show you how to start with a blank project or a new project which is completely blank. This is just a demo, creating this demo project. So once I have this, this is the most basic code that comes by default. So in this, you see that these are the basic minimum that you need. So the document class is article. So in place of article, I can have a book, I can have a thesis. These are all different class files. So this is the type of article that you would see. This is the type of PDF on the right that you would see when the document class is article. When I change it to thesis and recompile it, then it would be different because, of course, this is not able to compile because this is not the actual how do I put it? This is not the actual way of using the document class thesis. So I think now I should be able to compile this. Okay, so this is the class file of thesis is probably not included in this overleaf. So yeah, any of the standard class files that automatically comes by default. Yeah. So you can see here the formatting changes automatically. Just by changing this one keyword for the class file, the formatting changes automatically. Instead of an article, a book, or yeah, I can even make a presentation. And to make a presentation, what I need to use is Beamer. Okay, this needs some more details to use Beamer. So the actual usage is not so simple. So let's take it line by line. So this is a class file, and these are this is existing by default. This particular folder does not need to have this article here. But if this is something special, this has been created differently. We have a, I think we have a session where uh, you'll be able to identify how you can even make your own customized style files or class files. So you can even have whatever the way you want to prepare your article. That is also possible by changing the class file. So this article.cls, if you just Google it up, then you can find the source code also. So probably this would be there in the So these documents use the article.cls, so that is the reason this is showing. But the actual article.cls can also be downloaded from the internet. Yeah, this is the article.cls class file. I think this is presently opening or downloading. Well, this seems to be some missing link. Anyway, similar to article.cls, there's also an ELS article.cls, and this is used by all of the Elsevier publishing journals. All those journals which are published by Elsevier use this particular uh, document class or the class file, ELS article.cls. So if I go to this demo, then instead of article, ELS article is the, I'm not sure this would work, but yeah, this is working. So ELS article, this particular class file is already uploaded in the overleaf system, and hence this was able to compile this. So this is the format used by most of the Elsevier journals. So there are certain packages which need to be used for different usage. Meaning if I want to use figures, then I need to include the graphics package. And if I want to use equations, then basic equations can of course be included. But if I want some complex equations, then AMS Math is a very useful tool. So you can see AMS Math, and I can have AMS symbols to include some special symbols, and fonts can also be used for specific font styles within the equations. So these are some packages. Apart from this, there are several packages which can be used for algorithm, for appendix, for arrays, for bibliography, for captions, for subfigures, for different colors. This float is for working with figures. Geometry is a package to define what are the margins that you want in your article. Hyperref is a package which is useful to link different components. It could be within the document or it could be even outside the document. You can click on a link and it will take you to the destination. Similarly, Lipsum is one package which is used to generate random text, and that is sometimes useful to actually know how the floats or figures, equations, and tables are placed within a document. And long table is a package which is useful to generate very long tables which are spread over multiple pages. There are math tools also. There are multi-col and multi-row. These are useful for generating complex tables in which you need to merge multiple cells. Could be two, two cells of different rows or two cells of different columns. So for these packages are useful. And PGF is what I will be discussing about shortly. You can do a lot of things for figures using the subcaption, subfig, and subfigure. All of these have different uh, ways of being used. And ticks is what I would be discussing, of course, for to generate very good quality figures. And color, Xcolor is the package that's pretty helpful for working with different colors. So Tix is a tool which is very helpful for generating figures through text. So in a document, you need the title of what is the document that you're doing. Here, what I've put is demo instead of demo. I can put the demonstration of text for generating quality PGF. I just not able to recall what is the full form of PGF. PGF refers to it's PGF refers to portable graphics format. Just as we have portable document format, PGF refers to portable graphics format. So with this, the title can be changed, and this also came by default. You can put your own name, you can have a date, and the content of any document usually comes after the begin document command. And this make title starts the article. This compiles whatever is the title commands that are included here, and it is displayed after the begin document command. So within this, we have an introduction, and there can be different sections. You can have section introduction. I can have another section for text, demo, and I can have another section for conclusion. If I recompile this, you can see that these sections have come up, and here one thing to note is most or almost all of the numberings which are compiled by LaTeX are automated. You do not need to worry about any of the numbering formats. So that's taken care by the templates. So let me show you how text can actually generate figures. So in this same file, I am putting, these are some of the, this is some of the content which I had previously to demonstrate. So if you look at this single line, it says text draw with, this is a line which has a width of 1 millimeter. And these are the coordinates from, this is from, and this is to. So this draws a line from 0, 0 to 4, 0. So this is x1, y1, and this is x2, y2. So this is a simple line that comes. So you can see here. So if you want a horizontal, an oblique line, then you can just go for 4, 4, and it will give you a line at 44 degrees. Sorry, 45 degrees. So this is pretty simple when I'm talking about drawing a line. Similarly, if I want to draw, say, a circle, then I can also, I have a command. This says text draw line width of 5 mm. So the 5 mm here defines what is the thickness of the line that is going to be drawn. This has been quite some time since I've used this. This draws a circle, Yeah. So the 20 point here indicates what would be the radius. This indicates what is, I think, the center of the circle. So this, the alignment of these figures is slightly not so easy to follow when we are using these figures directly. Hence, the lipsum package is quite helpful. So this can generate some random text, and within that random text, we will be able to see how these different intents would be visible. Of course, if you look at any document, you would be having more of text and little bit of uh, figures and all that. And corresponding to that, the lipsum package generates a lot of text, and in between that text, you can have some of the figures. So similar to using the circle, we can also generate ellipse with different dimensions. So here, the major axis and minor axis are defined by these 20 point and 48 point. And this is the line width. So in LaTeX, you just use a space between two lines, then you get the commands in two different paragraphs. Actually, line space indicates a new paragraph in LaTeX. It's also possible to rotate these ellipses. So this is how an ellipse can be rotated. Depending on what is the angle that you put, you can rotate it to whatever angle that you wish to put. It's possible to also scale these. So you see these two commands are the same, except here the scale command is inserted in comparison with this. And you see that the size of the ellipse is 5 times of what you have here. So the advantage that you get by this way of generating figures is these are portable in nature. These graphics are portable. So whatever size that you want, that you can define here, and those sizes do not, those are not distorted. If you're familiar with figures, uh, uh, when you zoom into some figure, then you observe that there is some blurring. There is a blurring effect when you zoom in for some figures. But in many articles, as much as you zoom, you will find that there is no blurring at all. So that effect is only possible when you generate figures within LaTeX itself. Otherwise, you need to use specialized tools which generate scalar vector graphics, and those scalar vector graphics need to be saved in the proper format. Even if you use some very good tool to generate a scalar vector graphic, and if you save it as a JPG image, then the quality is lost. And when you zoom in, then you would be able to see the blurring effect. So beyond the basic shapes, you can always use lip-sum in these documents to include some random text so that you see, so that you're able to see how the figures are actually, how these figures are actually being displayed. So apart from this basic lines, if you want to have it, have these, yeah, you can indicate the color of a line also. So you can see the color of the line changes. So these are pretty simple commands which can be used. So if one wants a figure format, then this is the kind of template one needs to use. So this is a simple demonstration of how you can club multiple lines by using the simple draw command. So this is a line from the coordinate axis of 0, 0 to 0, 2, and there's another line from 0, 2 to 2, 0, and another line from 2, 0 to 0, 0, and there's another line which is connecting 0, 0 to 0, 2, and 0, 2 to 2, 2, and 2, 0 to 0, 0. So if you look at each of these lines separately, then you'll be able to identify how each of these are working. Okay, let me just separate out this section so that the well, this is the figure which comes with this particular command, and you see that this has come right at the top of the page, and this figure that should have been in the previous section that is coming after this. So this is because of the automatic formatting that is used by LaTeX. So there are some special commands which can be used. So I've used the simple command H to force the template to say that I want this figure here. I do not want it because this particular ELS article template uses any figures. It takes those figures to the top of the page. So that is the default setting. So if you want to change the default setting, then you need to manually specify that you want this figure here. So now I have the figure at the correct place. Another simple way, or instead of using this H, you can just use lip-sum, and you'll be able to identify that it takes the positioning by itself onto the next page, the top of the page. But now it has come after the section. Previously, it was coming before the section, but now when the text is there, then it comes after the figure. Yeah, so if you want this particular figure to be at the end of this text, then I need to specify this H command. Then you would see that at the end of this text, you will find the line or figure. So this is how this works. So if I want to draw the second line, then you can see that here another line gets added. So this is 0, 0 to 0, 2, and from 0 to this is 2, 0. So if I add this from 2, 0 to 0, 0, then this becomes a triangle. So instead of these, I can also use a single draw command, and I can have a square or a triangle also. I just need to remove this, and I should be getting, yeah, a triangle. So this is the syntax that needs to be used when I want to club all these commands into a single figure. I need to put this within a begin text picture and end text picture. Of course, these commands \text or begin text picture, you will not be able to use these commands and keywords if you do not use this text package. So this is a first initial necessary item. So apart from this simple figures, there are many complex figures that can be written using text, and you can also there's another example of a slightly more complex figure. So there's a these are commands uh, which show how you can join two nodes. So you can define nodes within this text command, and those nodes are indicated as you desire. So if you want a node without a circle, you can define it like this. If you want the nodes with a circle, then you need to define it like this. And so this line, this draw command actually links to these two nodes. So these are the positions of the nodes. And this is the command which is used to generate this rectangle with the nodes. So similarly, it's also possible to generate even algorithms or flowcharts So this is a much more complex set of commands. Okay, this is not complete. Probably missed something here. Well, one problem is, of course, with identifying what is the fault in the code. Of course, I think I have missed the packages. These are some specialized text commands, and these need some additional packages. So yeah, so there are many more text packages which need to be used for these codes to run. I think now this would be able to position. Some of the packages are probably outdated and hence not found. But this was a document which I have been using since long. Let me check this particular document. Well, you see, this works here. course, I used it in a different form. These are used text library. These are not used packages. And hence I'm getting the errors there. So you need to use these text libraries to be able to compile flowcharts like this. So the nodes are defined here, and these nodes, what is the shape of the nodes as rounded rectangle. All of these are defined initially, and after the nodes are defined, what is what you need means if I want a decision box, then how should the decision box look like? It's a diamond, right? So all of these can be defined here. And then all of these can be linked to form uh, algorithms or flowcharts like this. So if we have any questions, we can take up now. You can post your questions on chat. I'll be posting these codes on Canvas, so you can also fiddle with these codes and check how the output would come and what all modifications can be done. Of course, this is a code which shows circuits. So even electrical circuits can be drawn using this CircuitX package. So I'll just take a 2-minute break and then we'll start the second session on, yeah, I'll be sharing this code on Canvas. So you'll get access to that through Canvas. Okay. Yeah. Yeah. So going ahead, let's discuss about how we can work with posters. So there are different templates which are again available for posters. So if there is a template given, then you just need to put your own data into that template and you'll get the uh, formatting as per the desire of the publisher. So usually posters and presentations, usually posters and presentations use the Beamer document class, the Beamer class of style. And this is the complete template. And in this, so this is the starting of what this is. So this says that it's a Beamer poster, which this document is trying to do. And even here, the basic thing that you would want is the begin document. So the actual content, apart from the title and author and institute, those will be, of course, coming at the top. So the title, the names, and the affiliation and all that will be coming uh, at the top. That is defined before the begin document. And after the begin document, you can define each frame. So you can see here, this is one frame. So within the frame runs from here, till the end of this equation. So this is the entire content of text, which is okay. I think the frame here is defining that there are two columns in this poster, and this is the first column. Yeah, this is again saying there are two columns, and this is the first column, which has a 0.4, which is 0.4 times of the text width or the page width. And these are my different blocks. So itemize is used to indicate these points. Similarly, yeah, the alert block, that's what is given here, the alert block. And this is a way of writing equations. You can see this looks uh, pretty different from what is written here. But if you look at each of these items, then you would be able to identify what is the use of each. So this defines a vector, and nabla is this particular symbol like an inverted delta, and this is vector of h, and similarly this is vector of j. So backslash vec here stands for vector to indicate vectors, and backslash frac here says that you have two means a numerator and a denominator. So the first curly braces, this content indicates the numerator content, and the second curly braces content indicates the denominator content. So here the backslash and the square bracket, that indicates the beginning of an equation, and the backslash and the closing of the square bracket indicates the ending of the equation. Similarly, again, this is again another equation which has started and it is ending. So you can see here even symbols can be written like this. So there are different there are default packages which are being used for this. You can see here the maths and the symbols are being taken up from here, the AMS maths and the AMS symbol. So this is how you can have even mathematics, and an advantage of using this LaTeX syntax in your posters is that when you're creating a document using LaTeX, then you can directly copy your equations or figures or tables directly into this form, and you can compile it to get your LaTeX-based poster. So here you can see even text picture can be used to generate. This is yeah, I believe this is the equation that it is drawing. So, and these are the points which it is taking for x. So this is again another text picture wherein the equation that it is plotting is given here. This is 2 sine x plus sine x multiplied by 60 plus sine x multiplied by 720 by 2. So this is, you can directly plot content of equations in these plots. So this is a kind of how you would observe in an oscilloscope. And when you want to, so this is some random text which has been introduced here in this example block. So they've used this lipsum command. So this is just some garbage text. And after that, they have used a figure, and this figure is defined by this image name. So include graphics is the command which needs this particular figure name. So this 300 should be present within the same folder. This is the 300.jpg. So if you look at this poster, this looks good. But when you zoom this into this figure, then this figure would not be looking very clear. That is because of the formatting which is already there. So in order to get very good quality figures like this, it is going to be, if you want to generate such an image using TIGs, it's very complex. But these days, of course, AI is a very handy tool, and you can ask the AI to generate a text code for any image, and it would be able to give you that. So this is how posters can be generated. There's of course a template which I just picked randomly from the overleaf. So if you go and click on new project and click on these posters, then you have this poster template here. So you just need a overleaf login to access this particular template. Not just this template, but all the templates which are available here. There are numerous templates which are available. So if any one of you is organizing a session wherein a poster session or a poster presentation session, then you can give any of these templates, and you can ask the participants to fill in their content, and you'll be able to get the same structure in all your posters. So beyond this, if anyone is having any questions, this was a topic which I had to discuss on short notice. So I tried the best that I could. This would have been better if you would have understood more of LaTeX, but I think as we go ahead in this course, you'll be able to understand more on LaTeX, and you can come back and go through these files, and you'll be able to understand more of this. You can type in your questions in the chat box, or anyway, I'll be present mostly on all days. So we can discuss if you have any further doubts on these topics later on also. So I think we can close this session for now, and we'll start tomorrow's session. I believe you all have, there would be a session day after tomorrow that would be taken up by River Valley, it's a company that gives backend support to publishing houses like Springer and Elsevier to compile their LaTeX documents in the proper format. So they will be discussing more about pictures, and we also have another session on figures, about how you can generate figures and all that. Yeah, this is a very good question by Ankur. Can we use Overleaf for publishing research papers, or do we need to download LaTeX and write full code? Well, let me share my screen again. Well, if you are looking at the templates, you can take a look at IEEE journals template. There are many uh, journals which say that you need to compile it on Overleaf and then share it through Overleaf. That is one of the ways of journal submission also. There are some journals which are directly using Overleaf for accepting publications. Because as I was showing you earlier, this particular ELS article document I could not compile because I've used these which are actually uh, part of TIGS libraries and not actually coming as a package. So if anyone makes any error in these commands, then the document would not compile. You will receive errors. So in order to avoid these errors, uh, some of the publishing houses are asking for uh, submissions directly through Overleaf, meaning you can just go to, yeah, this is the journal, right? So you can directly say, well, there was an option to share. Sure. Well, yeah, there is, yes. And there is an option here at the top, submit to journals. So these are the journals which are directly accepting submissions. Okay, you can see a list. There are several journals which are directly accepting your research article through Overleaf. So this is of course very much limited now. It's not a very huge range of journals. Otherwise, of course, you can also share your LaTeX file with your supervisor, or could be your student or your colleague, and you can discuss how to improve the article. So collaboration is possible. And there is, of course, one drawback of using Overleaf, and that is security. You cannot be 100% sure that whatever you have put on Overleaf is completely secure. It's possible that someone else may be able to access your content even before it is published. So that is one small risk associated with this. So if you have some research content which you want to publish, then it is advisable that you download LaTeX. And of course, you don't need to write the full code. You can just use the template and then put in your data. Writing the full code in LaTeX is a very time-consuming process, and it would take a very long time to understand how to compile the entire document or put the exact commands. So it's always advisable to use a template and follow that. So I hope I've answered your question. Yeah, MikTeX is a tool which is actually a software tool to install the LaTeX compiler. MikTeX by itself does not have a compiler. Sorry, it does not by itself have a editor. So with MikTeX, you also need to use an editor. So if you're using Windows, MikTeX is the obvious choice because it's basically made for Windows. That's what I believe. So along with MikTeX, Text Studio is the editor which I commonly use. And if you're not using Windows, if you're using Linux, then TechLive is the standard TechLive is similar to MikTeX, but TechLive, of course, can also be used. I'll just type it here. TechLive is something similar to MikTeX, and it can be used on Windows or LaTeX or Linux. MikTeX is not that all that compatible with Linux, but TechLive is basically for Windows. MikTeX is there. Yeah, I'm not sharing anything. I just mentioned you can use TechLive in Linux. That's all. Yes, in Windows, MikTeX is preferred. And MikTeX is the backend. So you'll not be doing much with MikTeX, but you would need the front end, which is also known as the editor. So you need to keep in mind that you need to first install MikTeX. After that, after MikTeX is installed, you will have to install the editor, which is Text Studio, or there are a lot of this is all open source content. So you can download any of the editor like TechLive or Technic Center and use those. So tomorrow morning we'll be having our next keynote session by Dr. C.P. Ravikumar from Vinaya Tech, Bengaluru. He was a professor at IIT Delhi. So he would be talking about writing thesis and manuscripts tomorrow morning. So we are closing this session now and start tomorrow morning at 9. Thank you all.